Assalamu alaikum. So today we talk about the chain rule. So this is an important rule used to calculate the derivative of a composite function. So let's see how it works. So here we have the formula called the chain rule. So the derivative of the composite FOG of x is g prime times f prime at g of x. Or in Leibniz notation, we say that dy over dx is dy over du times du over dx. So here it's like we introduce a new variable u equals g of x. So we derive y at this new, with respect to this new variable, times the derivative of the new variable in terms of x. So let's see an example of the application of the chain rule. So here, an object moves along the x-axis, its position is given. So this is our function. So mathematically, this is what we are interested in. The question is to find the velocity of the object as a function of t. So we know that the velocity is the derivative of this function x with respect to t. So this is the question. And we see that here our function x of t is a composition of two functions, of the cosine function and of the polynomial t squared plus 1. So we can, for example, introduce a new variable u equals t squared plus 1. And in this case, our function as a function of u will be cosine u. And using the Leibniz notation, dx with respect to t is dx with respect to u times du with respect to t. So here, what is the derivative of x with respect to u? The derivative of cosine u is minus sine u. What is the derivative of u with respect to t? So here it's easy, the polynomial, it's 2t. And finally, we have just to replace u by its expression in terms of t, and we are done. So it's a minus 2t sine of t squared plus 1. So this is the velocity, dx over dt is this function used the chain rule. So this is another example. Differentiate sine x squared plus exponential x with respect to x. We can introduce a new variable, u, which depends on x squared plus ex. So the quantity here inside the sign. So we'll have f of u as sine u. And finally, df with respect to x will be df with respect to u times du with respect to x. So we calculate its expression. So df with respect to u, the derivative of sine is cosine. So here we have cosine u, whereas the derivative of u with respect to x is derivative of x squared is 2x plus the derivative of exponential x is exponential x times 2x plus exponential x. And finally, we express all the function in terms of x. So we replace u by its expression. X squared plus exponential x times 2x plus ex. And we are done. There are special cases where we can directly use the chain rule to obtain an easy formula. For example, the derivative of exponential of a given function u of x is nothing else than the exponential times du with respect to x. And this is an example. So what is the derivative of exponential x squared? It's exponential x squared times the derivative with respect to x2 of the exponent here, x squared. This gives me 2x times exponential x squared. Another example of the use of the chain rule. Here we have multiple composition. So we have tan of 5 minus sine 2t. This is called u. And we have also 2t inside sine. So this, for example, can be called v. Okay. So here we'll have g of t is tan of u o with v. Okay. So what is the derivative of g with respect to t? It's the derivative of the tan function with respect to u times the derivative of u with respect to v times the derivative of v with respect to t. The derivative of tan u with respect to u is sec square u. U of v is 5 minus sine v. So u prime of v, the derivative of the constant is 0. So minus cosine v. And finally, v of t is 2t. So v prime of t is 2. So if we replace here, du over dv is minus cosine v, and dv with respect to t is 2. Finally, it's plus minus 2 cosine v is 2t, sec square u is 5 minus sine 2t. And we are done. We have also a formula for the power of a function. So derivative with respect to x of u of x to the power n is n un minus 1, the derivative of u with respect to x. What does it mean? Let's see an example. So here, let's calculate this function, the derivative with respect to x of 5x cubed minus x4 to the power 7. So here, n is 7. N is the power of the function. It gives me 7. U will have 5x cubed minus x4 to the power 6. So we call this u. Du with respect to x. So 7, 5x cubed minus x4 to the power 6. What is the derivative of u with respect to x? it is, so let's come here, 5x cubed minus x4. So du with respect to x is 5 times 3 times x squared minus 4x cubed using the derivative of the power function. So times here 15x squared minus 4x cubed, and we are done. Let's see this example, the same idea. So here, let's say u of x is sine x. So d with respect to x of u to the power 5 of x, sine to the power 5, so u to the power 5, yeah, 5 u to the power 4 du with respect to x. So it's 5. We replace u by sine x, sine to the power 4 of x, and the derivative of sine x with respect to x. So here du with respect to x is cosine x. So times cosine x, and we are done.